Hello, and we are going to apply our formulas from trigonometry in order to figure out some different things. So the question is where do the double angle theorems come from? So where do the double angle formulas come from? And the first thing that you need to know is that you need to know your Pythagorean identities, and actually really only one of the Pythagorean identities. And you also need to know the angle sum formulas. So I'm going to start there. So the angle sum formulas pretty much start out with the fact that you're going to take the sine of some alpha plus some beta. And the formula that I learned for this was sine, cosine, cosine, sine. And when you did that, you were supposed to realize that you're going to do sine alpha, cosine beta, cosine alpha, sine beta, and you keep the sign right here. And that would be finding the sum of the angle measures with the sine curve. And so it's sine, cosine, cosine, sine. And then we did the cosine of alpha plus beta. And that went cosine, cosine, sine, sine, where we realized that we used the opposite sign here and you still did alpha, beta, alpha, beta. And the chant that we did in class was sine, cosine, cosine, sine, cosine, cosine, sine, sine. And that just helped us remember where these were. We had to know that we did the sines first and the cosines second, and that these signs were opposite of each other. And when we did this first in trig class, it was so that we could find exact answers to degree measures that we didn't know off of the unit circle. So for example, the sine of 75 degrees would be the sine of 45 degrees plus 30 degrees. And I would put my 45 degrees in for my alphas, I'd put my 30 degrees in for my betas, I would calculate everything out, and that would be the sine of 75 degrees. And then we practiced that using the radian measures. And so this would be the sine of pi fourths plus the sine of pi sixths. And when we worked all of that out, we would have to add up pi fourths plus pi sixths, which means that we would have to multiply this by 2 divided by 2, and we would have to multiply this by 3 divided by 3, and this would then be the sine of 5 pi twelfths. And then we could go and get all of our answers that way. So that's why we did it. What we're going to do is we're going to use this fact right here in order to figure out our double angle theorems. So I'm going to find the sine of x plus x. So my alpha is x, my beta is x, and that means that I am finding the sine of 2x. And if I use this formula right here, that means I'm going to use sine, cosine, cosine, sine. And I'm going to do the sine of x, the cosine of x. These are being multiplied together. I have a plus right side here, and it's the cosine of x times the sine of x. Lo and behold, sine times cosine, cosine times sine, there's 1. 2 of these. So sine of 2x is sine. Sine of 2x is 2 sine x cosine x. And that right here is our first identity. And we used this one here in order to get it. So thinking ahead, we're going to do the same thing now. Except now we're going to find the cosine of 2x. So I'm going to erase this stuff right here. And we're going to follow the same process. We're going to say, all right, I'm going to do the cosine of x plus x, which is the same thing as saying the cosine of 2x. And my chant goes sine, cosine, cosine, sine, and then I have cosine, cosine, sine, sine. I'll put the x in, it's a minus, an x in, an x in. And so this works out to be cosine squared x minus sine squared x. And I know it should not be sine squared plus cosine squared because that would be 1, and that's not the same thing as cosine 2x. So there's my clue right there. So going back up to here, I just got this identity. Now this fact right here is going to come into play to get the other two. So here's what I need to know. I have this identity here, and I'm going to say, well, I know that sine squared x plus cosine squared x equals 1. That means that cosine squared x equals 1 minus sine squared x. I'm doing algebra here. So that means that this is 1 minus sine squared x minus sine squared x, which is really 1 minus 2 sine squared x. That is also equal to cosine 2x. And then I can do this one more time. I can sit there and say, well, I also know that sine squared x is equal to 1 minus cosine squared x. So I start back up at the here. And so so I'm going to keep my cosine squared x, and then I'm going to subtract the quantity of 1 minus cosine squared x. And cosine minus cosine, there are 2 cosine squareds x minus 1. So all 3 of these boxes are equal to the cosine of 2x. And that's where these things come from. They come from messing around with a particular formula. You need to know one formula, you really need to know one identity, and then you can get all 4 of these.